In this lesson, we're going to talk about how you can use what you've learned so far about trigonometry in order to solve problems that might have two triangles in them. So oftentimes you might have to use a common side between both of the triangles, or you'll have to use information from one triangle to solve for the other one. There's a few different scenarios. So let's start with this first example. In this example, it's asking you to calculate the length of BC. So BC is the length of the bottom here. So what you can see is we've got one triangle on the left and one triangle on the right. We're going to have to solve for x first, and then we could solve for y. And if we add them together, that would give us the length of BC. So if I use this triangle here, I've got this angle of 60 degrees. X is the opposite, and this 8 is the adjacent. So I can use tan of 60 is equal to x over 8. Now remember, in order to do that, I'm going to do tan 60 times 8. That will equal x. So x is 13.9 centimeters. I can do the same thing, but now solve for y. So again, I've got this angle of 50, y is the opposite, and the 8 is still the adjacent in this other triangle. So again, I'm going to use tan, but this angle is 50 degrees, and that equals y over 8. So tan 50 times 8 gives me 9.5. So if I want to know the total from B to D, I just have to add these up. So 13.9 plus 9.5 is 23.4 centimeters. That will be the total length from B to C. If we look at this next example, it says calculate the measure of angle ABC. So when it lays out an angle like this, it means you're looking for the angle that goes between A, B, and C. So we're looking for this whole angle. So very similarly to the question above, we're going to have to solve for angle X first, and then we can solve for angle Y and add them together. So in this triangle, again, we'll start with the top one. If we label our sides, we have the opposite and we have the adjacent. So that means we're going to use tan, but our angle is unknown, and that equals 3 over 5. Remember, to solve for x, we would use tan inverse of 3 over 5. Which is 31 degrees. Similarly, for y, again, 5 is the adjacent, and 2 is the opposite. So, tan of y is 2 over 5. So y will be equal to tan inverse of 2 over 5, which is 22 if we round it. 22 degrees. So if we want the total for angle A, B, C, we're going to add 31 plus 22 will be 53 degrees, and that's the total. So 53 degrees will be the total for this angle here. In example 3, we have two office towers that are a certain distance apart. We don't know that distance. The shortest building has a height of 160.9, and the angle of depression from the top of the shorter tower to the base of the taller tower is 67. So from the top of this tower looking down to the base of the other is 67. And the angle of elevation from there looking up at the taller tower is 24. So we're looking to find the height of the taller tower. So if you notice here, what we've formed is two triangles. This triangle here, we know is 160.9, because from here to the ground is the height of the shorter building. So it's the same measurement as here. But we need to solve for x to be able to add this together in order to know the total height of the taller tower. So if we look here, in this top triangle, we know 24 degrees, but we don't know this side, we don't know this side, we don't have any other information. But if we use the larger triangle here, we could solve for side z using this angle and this side. If we knew side z, we could use that with the angle of 24 to solve for x. So let's look for side z. So again, in relation to the 67, this is the opposite, and this is the adjacent. It's just a coincidence that all of these are using tan. So tan 67 is equal to 160.9 over z. So remember, in this scenario, we just switch these places. So z will be equal to 160.9 divided by tan 67. So z is equal to 68.3 meters. Now, if we use that with this angle of 24, we can solve for side x. So again, we have adjacent and opposite. So let's do tan 24 is equal to x over 68.3, this side here. So here we've got tan 24 times 68.3. That will give us x. That's 30.4. And that's meters. So if we want to get the total height of the taller tower, we know that this part here, y, was 160.9, and this smaller part, x, is 30.4. So the total would be 191.3 meters. So that's how you solve problems with two triangles.